Hi and welcome. This is my first video, so I'm glad you are here. This is Code and Architecture with Jukka, and today I will show you Microsoft BitNet. Before we get started, if you enjoy learning about AI, coding and architecture, make sure to like this video and subscribe to the channel so you don't miss future demos. You can also find all the links mentioned in this video in the description below. So what is BitNet? BitNet is a research project from Microsoft that runs large language models on CPUs instead of GPUs. Normally, a language model needs GPUs for heavy matrix maths, and CPUs haven't been very good at that. BitNet changes this with what's called 1-bit LLMs. Instead of storing big decimal numbers, the model's weights use only 3 values, +1, -1 or 0. This means no big calculations are needed. Only simple adds and subtracts, which GPUs handle well. So why does this matter? GPUs are expensive and often hard to find, while CPUs are cheap and everywhere. In my own projects, I can always afford a small virtual machine that gives me plenty of GPU power. But getting access to the GPUs is a completely different question. So when you are just starting out, having the ability to run everything on CPU alone is very powerful. So in short, BitNet makes language models lighter and faster to run on CPUs. As BitNet works differently than regular language models, you can just take any model and run on it. Microsoft has trained a special model just for BitNet. It's called BitNet 1.58, and it has about 2 billion parameters trained on 4 trillion words of text. That's the official language model for this project. There are also ways to run other models. Some popular ones like Llama 3 and Falcon have been converted to work with BitNet. Now, to be clear, you can always run these models on CPUs, but without BitNet they would be far too slow to be useful. With the BitNet approach, they become much faster and more practical on CPUs, even if they don't quite reach the same quality as the official model. Now, in order to actually try BitNet, you normally have to jump through few hoops. You will need the right setup: Python, CMake and Clang. On Windows, that means Visual Studio with the C++ tools. On Linux, you usually grab LLVM with a script. Bottom line, it takes a bit of work to build from source. But your friendly host has made things easier. I created a Docker container that comes with everything ready to go. It compiles BitNet and Llama inside, applies CPU-specific optimizations for your machine by default, and then exposes the model through OpenAI-compatible API. If you don't want to wait for the optimized build, you can also switch optimization off for faster setup. Building it is simple. Check it out from GitHub, run Docker build, and then either run it directly or use Docker Compose. There are also advanced options. You can set number of threads, context window size, or even try different models like Llama 3 8 billion parameter model. Next, let's build the Docker image. The build process does take some time, so I have sped it up here for the video. In hindsight, I think it depends on what you're aiming for. If you plan to run this in production, then building with full optimization makes sense because you want the best possible performance. But if you are just experimenting on your development machine, you don't really need to wait for all the optimization. In that case, a simple, faster build is usually good enough. Good, and now our Docker build is done and we can follow up with running the container. Container is running, and the next step is that we start our little testing round. For testing, I will be using Chatbox. Chatbox is an open source tool that allows you to connect to different kind of language models. Essentially, it uses the OpenAI API for doing that. Now, for our first round, I think that we should be asking something simple just to test on how is the language generation capabilities of the model. So we start with something simple. Good day to you. Exactly. So as you can see, the sentence was nice and clear language. Let's proceed with something else. I'm explaining to the model on what we are actually now doing, and what I'm hoping is that we get a little bit longer answer this time. Yeah, that didn't work. So let's try something else. Anyway, as you can see, the model is quite snappy. So this is really a chat that works. Now I'm going now with a general line. This should force the AI to give a little bit longer answer, and we more or less got it. As you can see, the model generates good and coherent text, answers the questions as it should. Let's continue more. Let's ask it to explain why GPUs are used with generative AI instead of the CPUs. This is, I want to a little bit understand better on how much Microsoft actually put effort on teaching the model about itself. As we can see, we can now get a general answer. Again, the model produces good and coherent text, and more or less the facts are there as they should be. Now let's ask the model directly about itself. So I think that we can at this point say that the model is quite usable. I could imagine using this in a proof of concept or in a application that doesn't have an internet connectivity. All in all, I have been very happy on the way the testing has gone and how the model has performed. And as you can see, the model is aware of it to a point of itself. Amazing. Let's look at the terminal. BitNet does about 170 tokens per second on prompt pass and around 23 tokens per second while generating. For CPU only, that's solid. Snappy enough for live chat and smooth demos. Not GPU fast, but it proves you can build and iterate without one. For reference, this box is an underclocked Ryzen 3900X and interactive chat runs fine. On my old 2-core i3 ThinkPad, it's too slow for real-time chat, but fine for offline patch jobs. With longer prompts or bigger models, it will dip, but for this setup, the speed is genuinely usable. That's my quick BitNet demo and how to run it in Docker. If this was helpful, please like the video and subscribe for more AI, code and architecture demos. All links are in the description. Thanks for watching and I will see you next time.